All right, kids, so today what we're going to do is we're going to continue writing linear and exponential functions, but what we're going to do is we're going to write them from word problems / situations. So for this warm-up, what I'd like you to do for A and B, I want you to write either a linear or exponential function based on what you read. Pause the video, then play it to see if your warm-up was correct. All right, here we go. So part A. So the starting balance of this account is $1,250. So this right here, all right, whether it's exponential or linear, this is your y-intercept. Y-intercept is what we start with, the starting balance. All right, now it says that she takes out $30 each month. So she takes out 30 each month. So taking out means minusing 30. So if we're subtracting 30, that means this is linear. All right? Which means that our equation is going to be y equals m. So this minus 30 is going to be our m. So y equals minus 30 x. Now you put this over 1. And then plus b, and that's your 1,250. Weird. All right. Anyway, 1,250. Okay. And so that's our equation. That's our linear equation. Now the question says, after you write this, how much money is in your account after 3 months? So 3 months, what we're going to do is we're going to say, all right, what does months represent? Well, X is months. Because you're paying 30, you're taking 30 out each month. So we're going to go Y equals negative 30 times 3 plus 1,250. What we can do is we could pop this into our calculator, and we can say, all right, negative 30 times 3 is negative 90. So 1,250 minus 90 is $1,160. That's how much she has left after 3 months. Okay? So there you go. That is how much you have left. So dollars, and again, we want to answer with a word problem. We want to answer in context. So that's how much you have after so many months. So now part B says a population of 9,250 people each year. So again, started with this. So that started, which is your y-intercept. All right. So whether it's linear or exponential, that's your y-intercept. Now it says it's increasing by 8%. Now, increasing by 8% means that it's exponential. So our exponential equations are y equals a times b to the x power, or y equals a times 1 plus or minus r to the t. And t is really x. And this second equation, this is what we're going to use because our rate is our percent. So anytime you have a percent, you're going to use a rate. So again, when you write this out, we're going to go y equals 9,250 times 1. Now it says it's increasing by 8%, so plus 0.08 raised to the x power. That's our equation. Now it says predict the population in 6 years. So 6 is going to be our x, so we're going to put 6 in here, and then that's what you're going to type in your calculator. So you're going to get 9,250 times 1.08 raised to the 6th power, and you're going to get now a decimal. So we're talking about people. So you should get in your calculator 1,467,8.5,8,749, But because we're talking about people, we're going to say y is approximately 1,467 or 678. Because since you can't have decimal people, you get rid of that. So you say about people. And that's what we're doing. All right. So if you got that, well, today's should be relatively easy. We just have to be able to identify what is that rate of change or what is that multiplier that we're going up or down by. So we're going to write linear exponential functions and then use the equation to answer the question. So here we go. It says Pedro is holding a fundraiser. He's taking donations from his friends to support a charity. Each friend donates the same amount. The total amounts donated after 1, 2, 3, 4 friends give money are 15, 30, 45, and 60 respectively. So what we're going to do is we're going to match these up. So X is friends. So friends, and then Y is money. So what I'm going to do is I'm going to leave a space here. I'm going to put 1, 2, 3, 4. And then I'm going to match them up. One friend, oops, I don't know why that happened. So, sorry, 2, 3, 4. So one friend said gave 15, two friends gave 30, three gave 45, and four friends gave 60. All right. So what we have to do is we first have to determine, is it linear or exponential? So what we do is we say, all right, what is happening to our y's? Are they multiplying or are they adding? Well, it's adding by 15, adding by 15, adding by 15. And our x values are going up by 1, which is fine. So if we're adding by 15, this is your slope, which means it's linear, all right? And we know our m is going to be 15. So I know it's going to be y equals 15x. Now, plus or minus something, all right? Plus whatever our b is. So what we have to do is we have to figure out our b. Now, they didn't give our b. Our b is 0, comma, a number. So what we have to do is we have to work backwards. So if you add 50 to get to the next number, we're going to have to subtract 15 to get to our first number, which means our first number is 0. Now, do you need to write the plus 0? No. You can leave it like that. So our y-intercept is 0, 0. Our b is 0. So now, with using this equation, it says, how much would you get donated after 15 friends give money? Well, that means x is 15. So what we're going to do is y equals 15 times 15 plus 0. Really, it's just 15 times 15 is $225. There you go. And that's what we're doing today. So the second thing is Pedro collected $375. How many friends donated? So if you're getting 375, that's your y value, 375. So what we're going to go is 375 equals 15 times x plus 0. I'm not even going to write plus 0. So what we're going to do is we're going to solve for x. How many people gave money? So we're going to divide by 15. Divide by 15. What you're going to get is x equals how many friends? So 375 divided by 15 is 25. So we're going to say 25 friends. That's what we're going to do. But you can't answer D or E if you do not have this equation. This equation is crucial. All right? And you can't get this equation unless you make your table. All right? And you got to make your table. And what I encourage you to do is leave a space for 0. Leave a space. If there's no 0, you got to leave a space because we got to work back for our y-intercept. Cool? All right, let's go to the next example. Isaac invests his money poorly. After 1, 2, and 3 months, he has $300, $150, and $75 remaining in his bank account, respectively. So is this a linear exponential model? Well, let's first put it in a table. Leave a space for 0, go 1, 2, 3, and write down your money accordingly, 300, 150, and 75. So what is happening every month? After every 1 month, what's happening to our money? Well, if you think, maybe we're adding or subtracting, that's not what you're doing. What you're doing, if you add or subtract, it's minus 150 minus 75. That's not working. What's really happening is it's halving. So we're multiplying by a half, multiplying by a half. All right, which means it's exponential, and this is your b. So our b is 1/2. So the question is, how much did he start with? So that's the first one. So 0 is your y-intercept. So to go backwards, instead of multiplying by a half, we're going to multiply by 2. That's the opposite of multiplying by a half. So 300 times 2 is 600. He actually started with $600. So find the y-intercept, which is 0, 600. All right, which means he started with $600. And now it says write the function that represents the scenario. Well, since it's exponential, y equals a times b to the x power. We're going to go y equals a, which is 600, times 1/2, because you're losing the half every, is it months? Yeah. So now with this equation, we can say, how much would you have after 5 months? So pause the video and see if you can figure this out. All right. So 5 months, that means after 5, we're going to go y equals 600 times 1/2 raised to the 5th power. So you type that in your calculator, and you should get, now this is going to be fun, 18.75. And you can have decimals because it's money. So how much would you have to have? You would have $18.75. Wow, not much, starting with 600. Now some of you might be saying, doing this, Mr. Grauman, this is going way too fast. But you can always pause and replay that question, or pause and write down and practice this on your own. So now look at this one. This one, again, another problem, and we're going to go through the same routine. You're going to make a table to help yourself out. All right, I didn't give you one, but you can always make one. All right, and let's determine is it linear or exponential. So try this one when you're on, pause the video, and see if you get it. All right, Diana goes on vacation. Each day she spends the same amount of money. After 1, 2, 3, and 4 days on vacation, she has 242, 224, 206, and 188. So what we'll do, leave a space for 0. So we'll go 1, 2, 3, 4, and we're going to fill out our y values. So 242, 224, 206, and 188. Now, we've been practicing looking at linear and exponential functions. This is not decreasing quickly, so I'm probably not thinking it's exponential. I'm thinking it's linear. So let's see, what are we subtracting by? So what I do is I go 242 minus 224, and I'm going to get minus 18. So let's test it out. Is 242 minus 18 206? Well, 224 minus 18 is 206. And that's our common difference. Our common difference is negative 18. That's your slope. So it's going to be linear. Our slope is negative 18. All right. Our y-intercept. Now we have to find our y-intercept here. So we got to go back and get our 0 value. So instead of subtracting, we're going to add 18. So 242 plus 18 is 260. So our y-intercept is 0, 260. And that's our b value. So when we write it out, we're going to go y equals negative 18x, that's your m, plus 260. So now, using this equation, what we can do is we can now determine how much does she have after 7 days. Well, x is days, so x is 7, so we'll go y equals negative 18 times 7 plus 260. So how much does she have left? So negative 18 times 7 plus 260 is $134. That's how much money she's going to have left 7 days into her trip. And now, this is a good one. How long does it take her to spend all her money? Well, she spends all her money. How much money is she going to have? Well, her y value would have to be $0. What we'll do is we'll set our equation equal to 0. 0 equals negative 18 times x plus 260. What we'll do is we'll solve for the value of x. How many days will it take to get to 0? So we'll subtract 260, subtract 260. So we get negative 260 equals negative 18x. Divide by negative 18, divide by negative 18. Negative is positive. 260 divided by 18 is, now this is going to be a fun one. X will be approximately 14.4 repeated days. Now, can you have decimal days? Yes, you can. So we'll leave it like that. So it's somewhere, it's just under 14 and a half days it will take her to lose all of her money, or spend all of it, excuse me. All right. Now, let's do this one together because this one's a little fun. It has a 17%. Now, if you think you can do it, pause the video, see if you can do it without me doing it with you. All right? So here we go. The value of money of this car is depreciating. Each year, the car depreciates about 17%. Right away, I hear 17%, and I know I'm doing y equals a times 1 minus 0.17 raised to the x power. I know I'm doing it. This is your percent. All right? So it's 1 plus or minus r. That's the exponential one we're going to do. When you bought the car was worth $2,400. That's your a value. So it's going to be y equals 2,400 times 1 minus 0.17 raised to the x power. So we know it's exponential. Our function is right here. And what's the value of the car in 5 years? Well, 5 is going to be x, so x is 5. So we're going to go y equals 2,400 1 minus 0.17 raised to the 5th power. And this will type in 2,400, 1 minus 0.17 raised to the 5th power. And bam. We're going to get about, ready, 9,453.697, so we'll go 70. So that's how much the car is worth in 5 years. All right, so this is what I want you to do. Now that we've done 4 together-ish, I want you to pause the video, all right? And you have 5 and 6 and 7 left, all right? So, again, you don't need to do them all, but if you're not getting it, you should keep trying it, keep trying it, keep trying it. What I'm going to do is I'm just going to write the answers on the screen, all right, so you can check them. All right, if you have any questions, you can definitely ask them when I get back tomorrow, okay? So pause the video, and I want you to try 5, 6, 7, and then play the video, and you'll see the answers on the screen, okay? All right, great. All right, so here's number 5. All right, again, pause if I'm going too fast. All right, here's number 6. Now, number 6, I think, was the toughest one. They give you the y-intercept here, so I put that in red. And this was the hard one. How do you get that r value? Because it's not adding by the same amount. So what you do is you take the second number, for instance, 3740000, and divide it by the first number, 340000. All right, so you always take the, like a previous number, or like 1 divided by the 0 number. Take 2 divided by the first number. So what you'll get for all of these when you divide it is 1.1. So then you test it. Hey, is 340000 times 1.1 give me the next number? Take that next number, multiply it by 1.1. It is. So that's what you got to do. You take a previous number and divide it by the one before it. All right. So when you use that 1.1 for 10 years, 10 is your x equals 10. All right. That's how you get that answer of 881,872. And then the last one is the video game place. Charges you $10, and then each additional game costs 2. So 2x was 10. Cost for 4 games, so 4 is your x is 4. And then you simplify it to $18. And then if you have $50 total, so set it equal to 50, solve, and you're going to get 20 games you can play. All right, so what you're going to do right now is go up to the sub. Don't worry about that. And you're going to get worksheet number 2, which looks like this, day 2, okay? So what you're going to do, you're going to work through this, all right? The answers will be on Google Classroom. You are to do front and back, okay? Front and back. Have a great day.